We can use static analysis and reverse engineer the license check algorithm and write a keygen to generate valid keys. Obviously, this algorithm also can become very complex, but generally, if you put a lot of work in it, you can figure it out. Now, you tell that your manager, but he's a smartass and tells you, then you should stop people from being able to reverse engineer the binary. Then you direct yourself back to the desk and you come up with a new creative way how to stop somebody from debugging and reversing it. Because you are a pro, you understand that an executable is a very complicated file format. With object dump, we have seen that this executable has a lot of information in there that is needed to load and execute it. But you also realize that a program like GDB has to parse the executable to be able to disassemble and debug it as well. And Radare has to read and parse the executable file to show us stuff. So could you modify the executable in a way that you can still execute it with Linux, but GDB and Radare tell you that something is broken? What we are looking for is a parser differential. We hope that the parser from execve from Linux differs from GDB parser. We hope that the parser from execve in Linux differs from the GDB parser. In an ideal world, every program that reads input would do it in the exact same way. But every tool implements a parsing algorithm a bit different. So if you screw with the input, a Linux might see a valid file and executes it, while the GDB says it's broken and cannot be disassembled. Let me show you a very naive way how to find something like that. With fuzzing. So let's create a new Python script called fuzz.py. First we import some modules we need. Import random and import OS. First function you'll write is called flip_byte. As a parameter it takes a big string, which will be the whole executable file later. Then we select the random index I between 0 and the maximum length of this input. Then we select a random character that we will use to overwrite a byte in the program. So character byte from a random number between 0 and FF, which is 255. Then we return the original bytes up to this index I. The next character will be the random created one, instead of the original character I at this point, and we append the remaining original bytes. If you want to understand this fancy bracket colon index stuff in Python, just Google Python list. So just a quick example of this function. Print flip bytes and a string. With YY you can copy this line and with P you can paste it multiple times. And now you can see that a random character got changed to something else. With TD you can delete those lines again. Now we want a function that copies the original binary but flips a byte and saves it in another file. We call this function copyBinary. So we open the normal license 2 and a copy license 2 fuzz with write access. Now we read the whole original file, pass those bytes to the flip_byte function. Now this returns a copy of our license 2 executable just with a random byte flip, and then we write this to the new copy. Now obviously we flip weird stuff and the file might not be executable anymore. So we should check if the program still works the same way. This means that it should print access granted with a valid key. So this output should be the same for the original and the fuzz program. That's why I redirect this output to a file called original output. Now let's write a Python function that runs the fuzz binary once a byte got flipped, and let's check if its output is the same thing. A really ugly way how I do this now, just because it's less code. I execute the same command like I just did, just pipe the output into fuzz output. Now I add a function to compare the original output with the fuzz output, and also let the result return from the check output function. Okay, so this function checks if the binary still executes normally. Now let's think about how we can check if GDB still works. Basically, we don't want people to disassemble main. So you can use echo and pipe the disassemble main command into GDB to get the output. So this echo basically just types the command, and with the pipe we redirect this into the input of GDB. This looks good, so let's simply redirect this output also to a file that I will call original GDB. Now let's basically create the same function with checkGDB. And then we compare those two files again. Now let's do the same for Radare 2. Here we just use commands AAA, then seek to the main function and PDF, and also store this output in a file. And now again we create a check Radare function. You can use Shift V, which you can use to highlight multiple lines, and with Y you can copy it and paste it with P again. Okay, almost there. Now let's create an endless loop where we first create a new copy, then we check if the executable still works. If that works, we want Radare and GDB to fail. So not check GDB and not check Radare. If we reach this here, we print success. And we also print the tail of the Radare and GDB output, just to have a visual check if the disassembly really failed. With raw input, we can halt the Python program until we hit enter. Now let's run it. Another small mistake. This should be F1 instead of FN1. And I just discovered another mistake. Okay. It found something, but we clearly see disassembly there. So let's continue until we find an output without disassembly. Ooh, that looks good. Let's investigate. The binary still works. GDB can't find the main function. And Radare also has problems. Ha, that's cool. Admit this is very ugly. This is not a real good technique you should use in practice. But that is basically how fuzzing works, and how you might discover cool new tricks to hide your malware and make it harder for people to analyze it. If you want to learn more about this, you can read this one blog here, which calls this a novel technique, but it's not really new. And there's a bit more in-depth research on ELF file format from IOActive. And you can go even deeper and read even more crazy ELF file format tricks in the Holy International Journal of Proof of Concept or Get the Fuck Out, issue 0. My binary can be found in the GitHub repository, and you can try different tools like Hopper or IDA and see if they still analyze it automatically. But I suspect they do. So this is just one small trick which can annoy somebody trying to analyze it. Now you can go back to your manager and tell him that he should hire some web developers and move the product into the cloud so that the code only runs on the servers you control.